All right, hey everybody, we're here at the Pink Palace Museum. So we're gonna give you an overview of the project that we have completed this semester. So I am Sam Horne, and we have Jarret Joyner and Butler. We were our project team for the senior design course in electrical and computer engineering. So what we have here is our multi-plane hologram attraction. And so what you have is 3 parallel planes that reflect video off of a horizontal display. And so what that creates is the illusion of depth. So as the user approaches, they can experience the illusion of depth as they move their head from left to right and as they move forward and backwards to the attraction.
I'll show you how our motion sensor works. The kids can walk up, they don't have to touch it, so it's COVID-19 friendly. It limits the spread of COVID-19. So they walk up and they'll wave their hand under here, and it'll go to the next video. There's a timeout of about 5 seconds, so you have to wait five or so seconds until you can go to the next video and skip. So then it goes to the next one. Wait about 5 seconds or so. Then it brings it back. And after 20 seconds, it'll time out and go to the original video that you saw.
I was responsible for the facade here that mounts all of our hardware. We've got our speakers mounted in here, our motion sensor, and the Arduino. The separate screens are actually activated by the motion sensor being waved beneath. And that actually communicates with Sam's portion of it over the serial connection here.
My responsibility was the software component of the project. So you see we've got some components right here. We've got the Mac Mini, which runs the show. We've got this connected to our display using an HDMI cable. We've got the operator console, and then we receive a serial input from the Arduino over the serial port. And so what I've written is a Python script that accepts that serial communication from the motion sensor. So when presence of motion is detected, we trigger the next video. So how the algorithm works is it allows the user to wave their hand and trigger the next video in a sequence, and then after a certain amount of timeout, we play an interim video that loops until someone approaches the attraction again. And so what you see here is the timeout on the script, and then as it approaches 20 seconds, which is what we have set arbitrarily, it will trigger the interim loop. So I can go over to the video software, and if I want, I can manually override and trigger a video that will play. And this shows you how the screen is divided into the 3 sections right here.
I was in charge of the chassis and the cart for the actual project, and also making sure the acrylic panels reflected at the right angle and the right image size. So first I'm going to show you the cart structure. If you look under here, you can see how it has 2 runners and then a frame to actually hold the chassis, and a couple cross supports and a flat bar brace in the middle to support the chassis. And this is the control station for Sam to do all his work. Flips down and lock shut to keep all the components safe and free. If anybody's stealing anything. So if you come around the front, you can see the little facade that Chris built to house the speakers and the motion sensor. And then up here is displaying a grid. When we had the original 1/2-inch thick acrylic panels, there was a double reflection on the front side and back side of the panel. So we had to take that down, and on those panels you could see 2 of these grids lined up and offset and a 1/2 inch the width of the panel. But we had to go back to thinner panels. We're at a 1/16 of an inch, and you can't see that dual imaging. If you zoom in onto the grid, you just see a single grid with no double reflection. So another thing I was in charge of is making sure that when we actually plugged it in, that it wasn't going to draw too much power, that it didn't need a dedicated circuit. We didn't think it would, but we still wanted to calculate it and make sure it shouldn't draw anywhere over 10 amps. That's calculating and making sure everything is at max load. So when we go ahead and plug in our ammeter and current tester here, we're at about, where are we at? Bouncing around 6.8 to 7 amps. So that's right where we want it to be.